In this video, I'll be discussing relations and functions and specifically how to graph and identify relations and functions. The domain and range of a relation is all of the x and y values. So the domain specifically is all of your x values, and the range represents all of your y values. So right here in the domain, we are looking for all of the x values. So the domain of this relation would be all of the x values. So 0, -8, 1/2, -3. Now we do not have to write -8 again because it's already written here. The range of this relation is all of the y values. So it'd be 0, 4, 1, and we do not have to write 4 again because it's already written, and we also do not have to write 0 again because it is already written. So that would be our answer for the domain and the range of this relation. Now in this mapping, all of the x values are on the left and all the y values are on the right. And so to write the domain, you're going to list all of the x values, which is 1, -3, and 3. The range are all of the y values, which is 2, -4, and 4. In a coordinate plane, again, it would be just like before. The domain is representing all of your x values. So if you look at each one of these coordinate points, you're finding the x value of this coordinate point. So -4, this coordinate point is a 0. The x coordinate point of this is 1. And the x coordinate point of this and this dot would be 4. The range is all of the y values. So the range of this coordinate point is 1. The range of this coordinate point is 2. The range of this coordinate point is -3. The range of this coordinate point is 4. And the range of this coordinate point is -5. Also, you could rewrite these as the coordinate points first. So this is the coordinate point -4, 1. This is the coordinate point 0, 2. This is the coordinate point 1, -3. This is the coordinate point 4, 4. And then this is the coordinate point 4, -5. And then from these coordinate points, you can list the domain values and the range values. To determine if a relation is a function, all of your x values need to be different. X values need to be different numbers. They cannot repeat. So for the first relation, if you look at your x values, you have 0, -8, 1/2, -3, and -8. Because the -8 repeats, then the answer would be no, this relation is not a function, not a function. For the mapping, the best way to do this is to go ahead and write out these coordinate points. So the coordinate points would be 1, 2, because this 1, it maps to 2, and then this one also maps to a -4. This x value, -3, maps to 4, and then this x value of 3 also maps to 4. Now that you've written them as coordinate points, now you can look at your x values. Do any x values repeat? Yes. The 1 repeats, so therefore, no, it is not a function. In the last one, you would do the same thing. Are there any coordinate points to where the x value repeats? Yes. This coordinate point and this coordinate point both have the same x value. This is the coordinate point 4, 4, and this is the coordinate point 4, -5. Because the x value repeats, it is not a function. So again, your answer would be no, not a function. Using the vertical line test, you can also determine if a relation is a function. What you're to do is to draw vertical lines going through the graph. If it crosses only once, then it is a function. So for example, in this case, this would be yes, it is a function. However, on the second one, if you were to draw a vertical line, it crosses here and it crosses here. So therefore the answer would be no, not a function. And the reason is, if you crossed here at this point, it would be the point 2, 2. And if you crossed here, it'd also be the point 2, negative 2. Because the x value repeats, that's why it's not a function. Same thing here. If I was to draw a vertical line, it would cross the graph in 2 places. So the answer would be no, not a function. Because again, it has the x value would repeat if you were to use a coordinate point. So for example, here you have the coordinate point 0, 3, and here you have the coordinate point 0, negative 3. Because the 0 repeats, it's not a function. In this case, if you were to draw a vertical line, at first it looks like the answer would be no because it crosses. However, because this is a line, a point that is filled in, it does include it. But here, this is not filled in, which means it doesn't include it. Therefore, this actually, yes, it is a function. Again, the coordinate point is not included here, but it is included here, which means it does only cross in one point. Now, to find the domain and range from a graph, you're looking for first in the domain, how far left does the graph go and how far right does the graph go. So if you find the farthest left coordinate point is the coordinate point negative 5, 4. The farthest right coordinate point is 5, 2. So you're looking at the x values for the domain. So the domain goes from negative 5 to 5. It is a parentheses because these open circles mean that it does not include those x values. It's all the values that are in between. Now the range, on the other hand, is the y values. So if you're looking for the highest and the lowest that a graph goes, the highest point is still the point negative 5, 4, but now the lowest is going to happen here or here. It doesn't matter which one you use because they're both y values are the same. So I'm going to use the coordinate point negative 1. That's not the coordinate point. The coordinate point at that point is 0, negative 1. So if you're looking for the range, you're seeing how far low the y values go to how far high the y values go. In this case, negative 1 is included because it does hit negative 1. But as high as it goes is 4, but because of the open circle, it does not hit 4. So there should be a parentheses around the 4, a bracket around the negative 1. On the right, the domain, again, you're looking for the farthest left and the farthest right. The farthest left is this coordinate point right here, and the farthest right is this coordinate point. So don't forget, the domain, you're looking for the x values. So you go from negative 3.1 all the way to 3.2 would be your domain. Now the range is all of your y values. So when you look at the range, you're looking for how far low and how far high a graph goes. This is your lowest point. This is your highest point. Because it's the range, you're looking for the y values. So it's everything from negative 3 up to 3. And they are brackets because these are filled in, so it does include those numbers. Function notation, this is where you're going to substitute a value in for x. This is f of x, which is why the variable is denoted by x. And we're going to plug negative 2 in for x. So we'll get 4 times the value minus 10, and we're going to input negative 2. 4 times negative 2 is negative 8. Negative 8 minus 10 is negative 18. Now we're going to plug in 5 into our variable. So 4 times 5 minus 10 is going to give us 10. And now we're going to input an expression. So we're going to input x plus 3 into x. So it'll be 4 times our variable minus 10. But instead of our variable, we're actually going to plug in what we are substituting. And we'll have to use the distributive property, 4x plus 12 minus 10, which will give us 4x plus 2. And last, function notation graphs. we can actually find the values on a graph. So we are looking for, if this is the function of h of x, we're looking for what value will give us an output when we plug in -1. So we find -1, and we're looking for the y value at that point. So the answer will be 2. H of 2 means we're going to the 2 on the x-axis, and we follow the graph to see what the y value is, and the y value is 1. Now in this case, we're looking for when does the graph equal 3. So here is 3, so we follow the graph. So at which x value does the graph give us 3? And the x value is -4. And then here we're looking for when does the value equal 0? Well, it equals 0 here, and it equals 0 here. So what are x coordinates at that point? So we actually have two x coordinates, -3 and the number 4.